Alright, welcome to your first iChem lesson on density. Before we get started, as a reminder, while you're watching this video, I expect you to be filling out the viewing guide I provided for you, and then after that, take the mini quiz via Google form. You'll have pretty much all of the answers down in your notes if you are follow along with the viewing guide, and the mini quiz should be absolutely no problem. First of all, so what we're talking about is density. Density is a physical property. It's the mass of a substance per unit volume. In other words, it's how much matter or stuff is in a given amount of space. I think the idea of density is something that you're at least familiar with, and we're going to focus kind of more on learning how to calculate it and compare it and use that to identify metals and other objects. So for example, here I have 3 different metals: aluminum, silver, and zinc. If you look at them, they all look the same. But the density of aluminum is 2.8 grams per centimeter cubed. Density of silver is 10.49 grams per centimeter cubed. And the density of zinc is 5.61 grams per centimeter cubed. So even though they look the same, if you were to pick them up and put them on a balance and kind of compare their masses, if you had the same volume of each, you would kind of tell them apart. If I picked these all up and I had 1 centimeter cubed of each of them, certainly silver would feel the heaviest, because in 1 centimeter cubed it has 10.49 grams, where the others only have 5.61 and 2.8. So density is like, if you have the same volume, then you can compare the masses, which one's more dense. In terms of the math involved here, density is a ratio. It's the ratio of mass to volume. So we can write it a couple of different ways. In the equation like this, written as the ratio. In the equation here in words, density is mass divided by volume. I actually also have this triangle provided for you already on your viewing guides, and I just want to show you a little bit how to use it. So say you're trying to solve for density. I would cover up the D that stands for density in this triangle, and then the rest would tell me to solve for density, I would divide mass by volume. Now that's kind of obvious based on the equation, but sometimes you know density and you're trying to find one of the other variables, and then algebra becomes a thing, and I know that may not be everybody's strength. So let's say I wanted to solve for volume. I would cover up the V for volume, and I would see that if I wanted to solve for volume, I would divide mass by density. I could figure that same thing out by rearranging this equation using algebra, but these little triangles come in handy. So last thing, if I want to find mass, cover up the M standing for mass, and I would see that if I was looking for mass, I would multiply density by volume. This triangle, and all triangles a lot like it, you'll see them already around the room, will come in handy to you throughout the semester. So units are really important. We talked about that yesterday. Numbers are meaningless without units. The units of mass we know at this point is grams. Volume, we can use milliliters or centimeters. They mean the exact same, centimeters cubed, they mean the exact same thing. And then density is the ratio of those two quantities, so grams per milliliter or grams per centimeter cubed. So let's do our first example. Over fall break, a student goes mining for gold in the North Georgia mountains. He sifts the silt and water in the creek bed and finds a shiny gold medal. Did he strike rich? Well, he can take a little bit of data here, and the piece of information he was able to get were the mass of the object that he found, the volume of the object that he found, and he knows the density of gold. So the idea here is, can I find the density of this golden metal that he found in the creek bed? And then once I have that, let's compare it to the density of gold and see if it matches. This is actually how some metal identification is done, in the real scientific world, not just in the classroom. Okay, so calculating the density. Is it cold? I know from the equation that density is mass divided by volume. So here I put the mass on top and the volume on the bottom. I just plug that into my calculator and I get 19.3 grams per milliliter. Make sure I'm including the units every time. If you look here, when I write it in the ratio form, grams per milliliter shows up here, and then grams per milliliter shows up there. So I need to answer my question though, is it gold? Yes, because the density here pretty much matches the density here. Let's do another example that may involve a little bit more algebra. So you have a block. You want to know the mass of that block now when you're given the density and the volume. So you're given information. The density of the block is 0.78 grams per centimeter cubed. The volume of the block is 0.324 centimeters cubed. Now, you may have been able to look at that paragraph and just pull out those numbers and kind of skip this step, but I recommend really, especially now, we have two variables, but our equations might be getting a little bit bigger and you have more numbers to plug in. It's a good habit to get into to write out each of your variables. You don't have to write density of block. You could just write D equals, V equals, and so on, but get in the habit of writing out your given information. All right, so let's solve it. Plug what you know into the equation. We're going to do it two ways. First, the algebraic way. So here's my equation. I know density and I know volume. I'm going to plug those both in, and then I'm going to solve it using algebra. So density, mass, I'm just leaving there. I don't know what that is yet, and then volume. Now, remember, using algebra, to get mass to stand alone, I need to undo the math that's done to it. So it's divided by 0.324, so I need to multiply it by 0.324. When I do that, however, whatever I do to this side, I have to do to that side. So I'm going to multiply both sides by 0.324. That will cancel out over here and give you an equation mass equals 0.78 times 0.324. Now you don't necessarily have to include the units in the equation as long as you include the appropriate unit in your answer. It's 0.25 grams. See the centimeters on the bottom here, centimeters in the numerator here would cancel out and you would end up with grams. Now let's look at the triangle. Can the triangle make this a little bit easier? Well, yeah, it sure can. So remember I was trying to solve for mass up here, so I'm going to cover up the M here. And it tells me that to solve for mass, I want to multiply density by volume. That allows me to skip a whole step. I start just right here. And then multiply the two numbers together and end up with the same answer of 0.25 grams. All right, the last little bit I want to talk about is water. In this class, we'll be using a lot of water to make our solutions. It's sometimes called the universal solvent. Pretty much always, if it's liquid in this class, it's going to involve water. That's nice for you because water is special. When we're doing our calculations, we can use the density of water to be approximately 1 gram per milliliter. What that means is that there's the same number of grams in water as milliliters. So if I have 1 milliliter of water, I have 1 gram of water. If I have 20 milliliters of water, I have 20 grams of water. If I have 5,346 milliliters of water, it's 5,346 grams. This last one here involves a metric conversion, which we talked about a little bit in class today. I have 1 liter of water, which actually is 1,000 milliliters of water, remember? So I have 1,000 grams of water, which is actually 1 kilogram of water. Water is super useful because when you know the volume, you automatically know the mass, or when you know the mass, you automatically know the volume. And that's one important thing you need to keep in mind. We'll use it a lot in this course. All right, so you should have your notes filled out. If you don't already, if you miss something, go back, rewind. That's the beauty of these videos, is kind of take at your own pace. Then make sure you answer the questions on the Google form. The link is on the blog in the same place you found this video. This is an important step. If you don't do this, you don't get credit. Make sure you're answering the questions correctly, because you get the most credit if they're right. All right, see you tomorrow.